Good afternoon. The following video will give a short explanation of how to set up the WAM robot, both the hardware and the software. Before starting this tutorial, it's very important that you make sure that your computer and the WAM robot are connected to the same router, because the way we will be communicating with the WAM robot is through an SSH connection. Also very important is that all the code we use in this tutorial will be available in a GitHub repository. So right now in the upper right corner you can see the link to this repository, and I will also post this link in the video description. So let's get started. So the first file we will be working on is called discoverwam.py. So let's go to this file right now. So this file is very important because you won't probably know the IP address of the WAM robot once it is connected to a router. So this program was developed by Barrett Systems, and it basically will output the IP addresses of the WAM robots connected to the router where you are connected. So again, it is very important that you are wired connected to the router. You have to get an Ethernet connection, direct Ethernet connection to the router. The WAM robot should be also connected to the same router. And when you run this program, it will check in the subnet all the available WAM robots, and it will display this in the terminal. So the only thing you have to keep in mind of this file is that you have to change this variable called IP file. This IP file will be a txt file where the program will write the IP address of the WAM robot you want to connect to. This is very important because we will be needing that IP address when running further other programs. Okay, so let's move to the terminal and see how this works. So we have first to execute the program. Okay, so this program, as I told you before, makes a UDP request, and he finds only a single WAM robot in the network. But if you had more WAM robots to the same network, we will find more in the list. So we select the only one we found, and now we are ready to make the SSH connection. Now we have just to enter the password for the WAM robot, and we are ready in the terminal of the CPU of the WAM robot. Now we have to move to the following path. Okay, so in the folder tn/wam/nr6 we will find a program that it's very important, that it's called WAM server. So we execute this program. This is reading in C++, and this program will basically allow us to turn on the robot and start doing things with it. So as you can see in the terminal, the program asks us to shift activate the WAM. So we have to go to the controller, and we have to press simultaneously the shift button and the activate button. After pressing those two, we see that the robot is turned on and that the WAM server program displays a menu of options. So here basically we can query for the current position. So we're gonna see that we press D, and the program prints the current Cartesian position, the quaternion, and the joint position. We can do some other important commands. Here are the home, that will return the robot to the base position, and the idle command, that will free the robot so that we can move it freely without any resistance. Before continuing explaining more programs, it is important to really understand how does the WAM architecture works. So until now we entered the WAM CPU and we executed a program called WAM server. What we are going to do now is, with another program called WAM symbol client, we will establish a socket connection with this WAM server program and the WAM CPU. And with this socket connection, we will be able to send commands from the client, that it will be our laptop, to the WAM robot. And basically the WAM server will get these commands and move the robot according to what we want to do. Another very important thing is that the client, WAM symbol client program, is a ROS node, so you can use any of ROS capabilities to use the WAM robot. If we make a fast overview of the file, there are some important things we have to take care of. The first thing is this variable called IP file. As you can remember, we use this variable is basically the direction to a txt file where the client will take the IP address. So basically you just have to make sure that this IP file, it's the same direction that you use in the previous program, discover 1.py. Looking fast into the methods functions of this program, we can see the init socket method. This method will initialize the socket connection between the WAM server, and finally we can see some of the basic methods we can use with the client. So the first thing is create the joint position. So this will send a command and the WAM server will return the positions of the joints of the robot. We can ask also for the Cartesian position. We can send a command go to. So basically in this type of command you will send an array of a specific orientation where you want your robot to go, and it will go. And we can also specify the go to command with XYZ coordinate system. We have another method called go home, and basically this will make the WAM robot go to the home position. And it is very important that you be careful when you execute the commands go to joint or go to XYZ, because you have to make sure you are not putting random numbers. You have to make sure that the position you want the robot to go, it's a position where he can go, or the robot may get damaged. We go back to terminal. We make sure we have a ROS core executed, and now we will launch our ROS node with the command ROS run. So right now the program is looking for a socket connection in the WAM CPU. So we return back to the WAM terminal where we had the WAM server program running, and now we have to press the option C, and this will start the socket connection. The WAM simple program simply asks for the current position and current orientation of the WAM robot. So we can see here, this is the WAM robot CPU, and back here we have a live update of the current position and current orientation of the robot. So as we move the robot, we can see how the different numbers in the position and orientation of the robot changes. Finally, to turn off the WAM robot, it's really important that we don't end the connection in the WAM CPU. This will not be good for the robot, so it is better to simply finish the client's program. So here we're going to finish the program with Ctrl C, and once we finish the program, the WAM will go to the home position. Now here in the WAM CPU we simply type any key, and this will return us to the menu, and we have to press the option Q, and this will turn off the robot. Before quitting, WAM asks us to get back to the controller and push the shift and idle command. So we do it at the same time, and now we have the robot turned off.